my question is about vitamin D. What is the really difference between the active vitamin D 1.25 and the 0.25? And which one is really, so what is the connection for VDR receptor? Which one is important to look for? Anytime I supplement with vitamin D, my vitamin D 1.25 is rising. So I just cannot see the difference and the question.
So when you consume vitamin D or you get it from the sun, it's 25 hydroxylated in the liver to 25 OHD, and then it is 1 hydroxylated primarily in the kidney to 125 dihydroxyvitamin D. And that circulates in the blood as an endocrine hormone that is primarily serving to regulate serum calcium. And then there are many other cells that can also take 25 OHD and convert it to 125 themselves. Although it's controversial how much 125 any cell gets for itself versus from the blood. And so, for example, in immune cells are one of the major cells other than the kidney that can make their own 125, although there is significant evidence that they're actually getting most of their 125 from the blood and are just making a little bit more themselves. Classically, in the sort of like standard explanation, they'll tell you that 125 is what's acting on the vitamin D receptor, and that 25 is acting as a reservoir for it in the blood. And that the reason we look at 25 when we measure vitamin D status and not 125 is because 25 is generally going up when you are better nourished with vitamin D and down when you're not, whereas 125 is generally strongly regulated and is not going up and down as easily as 25 will according to nutritional status. If you dig deep into the molecular mechanisms, I think it's a little bit more nuanced than that, because although 125 is 1,000 times more effective at activating the vitamin D receptor than 25, there's about 1,000 times as much 25 as 125 in the blood and probably in the cells. So if you take the two of them together, they're probably having equal activity on the vitamin D receptor on average, because one is 1,000 times more potent and it's 1,000 times more scarce, and the other is 1,000 times weaker but 1,000 times more abundant. And so my suspicion is that if we were to, and it so happens that it's also the case that 25 is usually reported in units of nanograms per milliliter and 125 in picograms per milliliter, which are 1,000-fold different. And so you could actually take those two numbers and add them together, and you have an apples to apples comparison, because you're adding the thing that's 1,000 times weaker and 1,000 more abundant in units that are 1,000 times larger to the thing that's 1,000 times stronger, 1,000 times more scarce in units that are 1,000 times smaller. That was quite a mouthful, but what that means is that if your 25 is 50 and your 125 is 50 and you sum 50 to 50 to 100, that is probably a pretty reasonable depiction of the total biological activity. And you could do the same addition at 25 and 75 or 15 and 40, and it's always going to scale together.
So then I still don't understand why we don't measure both every time, because mine 1.25 is always on the highest normal range, let's say normal range around 70. And then the 0.25 is always on the lowest around 30. So that it means I'm around 100 and that is okay. And you would not supplement?
I think it depends on the response to the supplementation. So I actually am, I don't advocate the standard approach at all. I think it's a mistake to not measure the other things in the pathway, but I think it's also a mistake to not measure PTH. And so my PTH is basically your body's cry for help to get more vitamin D and calcium. And so when PTH is in the upper half of the normal range, it's too high, and it indicates that you have a deficiency of one or the other. Usually 125 is like, if let's say PTH is 20, which is in the bottom third of the reference range, you probably don't need more of either of those things because your PTH is probably maximally suppressed. It probably wouldn't go down any further if you added more vitamin D or calcium. Now, on the other hand, let's say your PTH is in the top half of the reference range. If it's 40, then your body is signaling that you need more of vitamin D or calcium. In that case, then usually the 125 is going to be higher when your problem is you don't have enough calcium, and your 125 is going to be lower when you do have enough calcium, and so it's probably more a vitamin D thing that you need. So the algorithm is, first, is PTH in the bottom half or the top half of the reference range? If it's in the top half or higher, you have a problem. If it's in the bottom half or lower, you don't. If you have a problem, then you go to the next step, which is the calcitriol towards the top of the range or towards the middle of the range? If it's for the top of the range, you should look at your calcium intake. If it's substantially lower than 1,000 milligrams a day, you should consider it plausible that you need to add more calcium. Whereas if it's towards the middle of the range or certainly towards the bottom of the range, then you probably need more vitamin D. And that's not an absolute rule, but it's a general probability factor. And so you should also consider, like, do I eat vitamin D? Am I supplementing? Do I get outdoor sunshine? Is my calcium intake 100 milligrams a day or 1,500 milligrams a day? So you have to look at those things. But in that analysis, you should bias yourself towards thinking you need more calcium when the 125 is higher, and bias yourself towards believing you need more vitamin D when the 125 is lower.
Awesome. Thank you so much.
You're welcome. All right. Take care.
You too.